Hello, sir. This is T. Kushi from ITA, and my roll number is 37. And my topic for Tech Talk for Java is memory management in Java. So, before knowing about the memory management in Java, let us know what is Java, why is it more important than other programming languages, what is the difference between other programming languages such as C and C++ and Java. So, coming to C and C++, these languages are platform dependent languages. So, they are being performed or they can be used only in particular platforms, whereas Java is a platform independent programming language. So you can write any code and run it on variety of CPUs. This is the main advantage of Java when compared with C and C++. And the main features in Java is object-oriented programming language. It is very simple and it has high security. That is, it is very secured programming language. As I told already, it is platform independent. It is robust, portable, and architecture neutral. So it has a good architecture and it is dynamic, interpreted language. It has high performance, it has multi-threads, and it is always distributed. As it is object oriented, it has classes and objects, as you all know. So these are some of the main features of Java. So now let us get into the topic. So our topic for today is memory management in Java. In Java, memory management is the process of allocation and deallocation of objects called memory management. So allocation and deallocation of memory is called as memory management. So you can allocate the memory for particular objects. You can deallocate the memory if it is not required. So that is called as memory management. So Java does memory management automatically. So Java does memory management automatically. So it is inbuilt. Java uses an automatic memory management system called a garbage collector. Thus, we are not required to implement memory management logic in our application. Java memory management divides into two major parts. The first one is JVM memory structure, and the second one is working of the garbage collector. So, first we'll know about JVM memory structure. So, coming to JVM memory structure, JVM creates various runtime data areas in a heap. These areas are used during the program execution. The memory areas are destroyed when JVM exists, whereas the data areas are destroyed when the threads exist. So here you have a main point. When JVM exists, then the memory areas are destroyed. And when data areas are destroyed, that means threads exist. So you can see in the picture, you'll have in a JVM structure, you have some of the things like method area, heap area, stack area, PC registers, native method stack. So this is the memory structure of JVM, as you can see in the picture shown below. So first we'll know about method area. Method area is a part of the heap memory which is shared among all the threads. It creates when the JVM starts up. It is used to store class, structure, superclass name, interface name, and constructors. The JVM stores the following kinds of information in the method area. So let us know what type of things or what type of objects are stored in method area. The first one is a fully qualified name of a type. So a fully qualified name. So generally names comes under strings. So in method area, we are going to store strings. Next is the type modifiers. Types, direct, superclass names. It is also going to store superclass names. And the last one is a structured list of the fully qualified names of super interfaces. So these are the four things which we are going to store in the method area region. So coming to heap area stores the actual objects. It creates when the JVM starts up. The user can control the heap if needed. It can be of fixed or dynamic size. When you use a new keyword, the JVM creates an instance for the object in a heap, while the interface of the object stores in the stack. There exists only one heap for each running JVM process. When heap becomes full, the garbage is collected. So coming to heap, in heap area, we are going to store or we are going to allocate the memory for actual objects, and any new keyword has been given or any new thing is given, immediately instant memory is allocated in heap area only. So once the heap area is filled, then it starts collecting, then the garbage is collected and it is made free for the memory allocation. And you have to remember another point is that there exists only one heap for each running JVM process. So when compared to stack, heap memory is larger in size. So we are going to, stack is also a memory unit where you store lists mainly. Stack is nothing but first in, last out. It works on that logic. So we are going to compare stack with the heap memory. So the first point is, when compared to stack, heap memory is larger in size. The garbage collector automatically removes any unnecessary objects from the heap memory. The heap's memory does not have to be contiguous. That is, it cannot, it is not needed to be continuous process. It is not needed like that. JVM gives the user the option to initialize or change the heap size as needed. The Java Virtual Machine. So JVM full form is Java Virtual Machine, throws an out of memory error whenever a calculation needs more heap than the automatic storage management mechanism can provide. So an object is given a place in the heap when a new keyword is used, but a reference to the same object already existing on the stack. So here you can see string builder SB is equal to new string builder of. So the above statement creates an object of the string builder class. The object allocates to the heap and the reference SB collects to the stack. Heap is divided into following parts. So heap is divided into following 5 parts. First is young generation, next severe space, next old generation, next permanent generation, and the last one is code cache. Let us know about these parts a bit deeply. So coming to the first one, young generation, all new objects are assigned and aged in this location. When this is full, there is a small garbage collection. Coming to old generation, long-lasting items are kept in this location. A threshold for the object's age is specified when it is placed in the young generation, and once it is met, the object is transferred to the old generation. Permanent generation. This compresses JVM metadata for the application methods and runtime classes. As you all know, JVM is Java Virtual Machine. So this is a small example for heap area, small program. So you are creating a class and in that you are given string first name, string last name and int age. These are the 3 parameters. And next you are creating a constructor that takes first name, last name and age as a parameter. So after that you are using this keyword, this dot first name is equal to first name, this dot last name is equal to last name, this dot age is equal to age. After this, you're going to create the main section and you're going to create an object to the person class. So here the class created is nothing but person class. So now we are going to create the object for the person class. So person P. So here P is the object is equal to new person of John Doe, 30. So these are first name, last name and age given. So in Java, you use system.out.println for getting the output. So for getting the output, you're going to give these 3 statements, system.out.println p.first name, p.last name, and p.age. So after running this program, the output will be John Doe 30. That is, the first name will be printed, the last name will be printed along with its age. Coming to stack area generates when a thread creates. So whenever a thread is created, then stack area has been implemented or used for the memory allocation. It can be either of fixed or dynamic size. The stack memory is allocated per thread. According to the thread, it is allocated. It is used to store data and partial results. It contains references to heap objects. It also holds the value itself rather than a reference to an object from the heap. The variables which are stored in the stack have certain visibility called scope. As you all know, you will have scope of the variable. So that is what has been explained here. Next, coming to the stack frame. Stack frame is a data structure that contains threads data. Thread data represents the state of the thread in the current method. It is used to store partial results and data. It also performs dynamic linking, values returned by methods, and dispatch exceptions. When a method invokes, a new frame creates. It destroys the frame when the invocation of the method completes. Each frame contains own local variable array, that is LVA, operand stack, that is OS, and frame data, that is FD. The sizes of LVA, OS, and FD is determined at the compile time. Only one frame is active at any point of the given thread of control. This frame is called the current frame, and its method is known as the current method. The class of method is called the current class. The frame stops the current method if its method invokes another method or if the method is completed. The frame created by a thread is local to the thread and cannot be referenced by any other thread. Native method stack. It is also known as C stack. It is a stack for native code written in a language other than Java. Java Native Interface JNI calls the native stack. The performance of the native stack depends on the OS. What is OS here? So in the previous slide, we have already defined that OS is nothing but operand stack. So coming to the PC registers section. So each thread has a program counter. So PC is nothing but program counter register associated with it. PC register stores the written address or a native pointer. It also contains the address of the JVM instructors currently being executed. So as you can see in the picture, it has reference value. It has an object array. It is the link between stack and the heap. So now we have been completed about the JVM memory management. Now let us know about the garbage collector. We'll have an overview about these. So when a program executes in Java, it uses memory in different ways. The heap is a part of memory where object lives. It's the only part of memory that involved in the garbage collection process. It is also known as garbage collectible heap. All the garbage collection makes sure that the heap has as much free space as possible. The function of the garbage collector is to find and delete the objects that cannot be reached. So the main function of the garbage collector is that it have to find and delete the objects which cannot be reached or which are not being used or utilized. So such objects are to be removed so that it can make more memory and it can make more space. So coming to object allocation, when an object allocates, the JRocket JVM checks the size of the object. It distinguishes between small and large objects. The small and large size objects depends upon the JVM version, heap size, garbage collection strategy, and platform used. The size of an object is usually between 2 to 128 KB. The small objects are stored in the thread local area, which is a free chunk of the heap. And TLA does not synchronize with the other threads. When TLA becomes full, it requests for new TLA. On the other hand, large objects that do not fit inside a TLA directly for large objects, the space is allocated in the heap. If a thread is using the young space, it directly stored in the old space. The large object requires more synchronization between the threads. What does Java garbage collector do? JVM controls the garbage collector. JVM decides when to perform the garbage collection. We can also request to the JVM to run the garbage collector, but there is no guarantee under any conditions that the JVM will compile. JVM runs the garbage collector if it senses that memory is running low. When Java program requests for the garbage collector, the JVM usually grants the request in shorter order. It does not make sure that the request is accepted. The points to understand is that when an object becomes eligible for garbage collection. So every Java program has more than one thread. Each thread has its own execution stack. There is a thread to run in Java program that is main method. Now we can say that an object is eligible for garbage collection when no live thread can access the garbage collector. Considers that object as eligible deletion. If a program has a reference variable that refers to an object, that reference variable available to live thread, this object is called the reachable. So only the reachable objects which are declared and used in the main section can be eligible for garbage collection. This is the point from this slide. Here a question arises, can a Java application run out of memory? The answer is yes. The garbage collection system attempts to objects from the memory when they are not in use. Though if you are maintaining many live objects, garbage collection does not guarantee that there is enough memory. Only available memory will be managed effectively. So you have many types of garbage collections. One is serious garbage collection. Given that it mostly relies on a single thread, this is the simplest garbage collection implementation. Because of this, whenever this garbage collection implementation executes, all application threads are frozen. Therefore, using it in multi-thread applications like server environments is not a good idea. Next is parallel garbage collections. It is referred to as a throughput collector and serves as a JVM's default garbage collector. It uses several threads as ops to serial garbage collector to manage memory space, but it also pauses other application threads while doing garbage collection. So the next one is CMS collector, that is concurrent mark sweep collector. So multi-garbage collector threads are used by the concurrent mark sweep garbage collector to collect the garbage. It analyzes the heap memory to identify instances that should be swept. Then it marks such instances for eviction. It is made for programs that can afford to share processor resources with a garbage collector while they are operating and that want shorter trash collection process. The CMS collector employs more CPU than the parallel garbage collector to ensure faster application throughput. The CMS garbage collector is recommended over the parallel collection if we can assign additional CPU for better performance. Coming to G1 garbage collector, the G1 garbage collector is made for programs that use multi-processor computers with a lot of memory. It divides the heap memory into two sections and performs parallel collection with each one of them. Just after reclaiming the memory, G1 simultaneously compacts the free heap space. However, in stop the world conditions, the CMS trash collector compacts the memory. The G1 collector will take the place of the CMS collector because it performs better. Coming to Z garbage collector, Z garbage collector is appropriate for the applications that demand low latency and employ a very large heap since it executes all expensive work concurrently without passing the execution of application threads for longer than 10 minutes. Oracle documentation states that multi-terabyte heaps are supported. Oracle made Z garbage collector available in Java 11. Cycles are completed by the Z garbage collector in its threads. It typically pauses the application for 1 milliseconds. The parallel and J1 collectors have an average of about 200 milliseconds. So the conclusion is that memory management in Java refers to the process of allocating and freeing up space for objects. Java memory management is divided into two major parts, that is JVM memory structure and working of the garbage collector. In Java, memory model explains how threads communicate with one another through memory in the Java programming language. The objects of the programs are stored in various locations in the JVM memory structure. Process of freeing space in the heap for the collection of new objects is known as garbage collector. So here we have come to a conclusion that in Java, memory management is nothing but freeing memory for creating new objects, and it is divided into two main parts, that is JVM memory structure and working of the garbage collector. So in this whole presentation, we have learned about these two topics in clear way, and hope you all understood this. Thank you so much.